Hello and welcome to another pre-recorded lesson for Math 1700. Today's lesson we're going to be doing the word problems practice sheet that you can find on D2L. It's called Linear Applications on D2L. So make sure you go and find that. It's in the worksheet section of Unit 1. Let's get started. The first question here is very similar to the one from your notes. In the notes I believe it deals with adult tickets and children's tickets. So the labor costs for a certain new project is $15.01 a day, or $1,501 per day, for 17 technicians and helpers. If the techs earn $92 per day and the helpers earn $85 per day, how many of each are employed? So we got to try and break this down. The question is how many of each are employed. So we need to set up a variable. Let's say let t equal the number of techs that we have, because that's ultimately what we need to figure out. And then we're going to need to figure out how many helpers are employed. And from the notes, you'll remember that if we know a total, for example, we know that we have 17 technicians and helpers, then the remaining helpers must be 17 minus the number of techs. All right, that's the number of helpers. And remember that that's because your techs plus your helpers, h I guess, would be 17. That means that your helpers would be 17 minus t, which is why that works out. But I don't want to deal with the second variable. That's why I just use 17 minus t. So that's your first step. That's what you're going to want to set up first for this kind of thing. The second step is you're going to want to figure out an equation. And in that case, we know that we have $92 per hour per day for the techs. And we have $85 per day for the helpers being 17 minus t. That cost together, or the labor costs together, will be your daily cost, $15.01. So once again, this 92t is the cost of your techs, and this 85 times, this is really the helper cost, or the helper number, the number of helpers. That together will be your total cost, which is why I worked it out that way. And all you need to do now is expand that out. So you have 92t plus 85 times 17 is 1,445 minus 85t. And again, if you know what I'm doing by this point, you can fast forward the video. And then we group like terms on the left side, it leaves 7t. And on the right side, 1501 minus 1445 is going to be 56. Divide both sides by 7 and you get 8. That's the number of techs. It doesn't take very much effort after that point to figure out the number of helpers. 17 minus t is the number of helpers, which means 17 minus 8, or 9 is the number of helpers. All right, so it's really a three-step process. Set up your variables, solve for one of those variables, and then as your third step in this case, figure out your last variable. And then you're going to want to write out the answer. So there are, you can just fast forward this, there are 8 techs and 9 helpers. I kind of ran out of space there, but you get the idea. Okay, so the next set of problems is a little bit different, and it's called mixtures. It's when you mix a group of substances together to make different percentages. So for example, let me read this question. I can make it a little more clearly for you. A man has 2 piles of solder, which is a mixture of tin and lead. He has 2 piles of solder available. One pile has 30% tin. The other pile has 70% tin. How much of each of those piles must be used to make a 20 kilogram mixture that would be 45% tin? So it's got to be a mixture of both, because, you know, if you just use the 30% pile, it's going to be 30% tin. If you just use the 70% pile, it's going to be 70% tin. So it looks like for a 45% tin pile or mixture, it's going to be mostly 30%, but you got to add some 70% in there to bulk it up. So this is what we're going to do. Just bear with me here. You're going to say, all right, I've got a 30% mixture added to a 70% mixture is going to give me a 45% mixture. And I know those percentages don't add up to 100, but that's not the point. It's 30% tin, 70% tin, and 45% tin is what I'm getting out of this, okay? So I'm going to put them in boxes. just to show you what's going on. I don't know where that 4 went. 45%. And then what else I need? I need to figure out how much the amount of the tin needed in kilograms. So as a side note here, let me just move this over because I should have done this before. I'm going to let x equals the amount of 30% tin mixture needed. Okay, just follow with me here. I know it's a little confusing the first time around, but just bear with me. The first pile is 30% tin, and so I'm just going to call that x. That's the amount of 30% tin, right? That's you had to call one of them x. You had to figure out the value somehow. So that's going to be what I'm comparing everything to. And finally, the 70% tin, well, let's leave that. Let's figure out how much do I need of the 45%. I need 20 kilograms. Okay, so I need some amount of the 30% mixture. I'm going to need some amount of the 70% mixture. I know that I have 20 kilograms of the 45% mixture. So this blue stuff is the amounts in kilograms. Now, one more thing. This x plus something is going to give me 20 kilograms. So without too much extra thinking, you should be able to figure out that the amount of the second one can be represented as 20 minus x. Because some amount plus, the rest of it, 20 minus that, has got to be 20 in total. So take a moment to think that through, okay? So our steps are set up the percentages, set up an unknown that we're going to be looking for, and then set up the actual amounts. Once we have those amounts, the fourth thing we're going to do is going to multiply them together, okay? This is what this looks like. 30% is actually 0.3 as a decimal. Multiply it by the x. Plus 70% is 0.7 as a decimal. Multiply it by 20 minus x. All right, you can see that they're multiplying top to bottom here. Equals 45%, or 0.45, times 20. Now that I have this set up, I can solve for x. So you can go ahead and pause the video and try that if you want. The answer you should get is 12.5. But if you want to watch me do the steps, go ahead. So 0.3x. 0.7 times 20 is 14. 0.7 times negative x is negative 0.7x. Equals 0.45 times 20, 9. I'm going to group like terms on the left side. And I'm going to bring the 14 over to the right side, and it becomes a subtraction. It gives me negative 5. If you divide both sides now by the negative 0.4, I end up getting 12.5, which is actually going to be kilograms. You can box it, because we're done. So the amount of 30% tin needed is 12.5 kilograms. Our fifth step is to figure out how much of the other mixture, this one here, okay? And that's really simple. Just calculate out 20 minus x. That's 20 minus 12.5. Some of you might even be able to do that in your head. It's 7.5 kilograms. All right, so in the end, as our final answer, we need 12.5 kilograms of the 30% mixture and 7.5 kilograms of the 70% mixture. And if you remember, if you rewind a bit, what I said was that it's going to be mostly the 30%, but we need a little bit of the 70% stuff to bring it up to 45%. And that's what we see. You see that you have mostly, 12.5 kilograms of the first mixture, but we've bulked it up with a little less of the 70% mixture. All right, and that's how we do these mixture problems. The next problem is exactly the same, just looks slightly different. So what I'm going to do is I'm going to post the solutions in a second, but I'd like you to try it yourself, okay? So pause the video, and then I'm going to post the answer here, and you can pick through it at your leisure after. I'm not going to explain this next one, because it's the same process. All right, so pause the video. Okay, and here we go. So you can see that the structure is basically the same. If I move up here, you can see that all the major steps are there. You've got your mixture percentages set up. You've got your statement of what your variable is going to be, in this case the 90%. I set up my amounts underneath the mixture, and then I'm multiplying this by this, this by this, this by this, right? Doing your multiplies. And the rest kind of shakes out exactly the same way. That's why I didn't do it. Number 4 is, again, pretty much the exact same thing. We have a certain roadbed material, 75% crushed rock this time. The other is 30% crushed rock. How many tons of each must be mixed to make a 250 tons of a material that's 50% crushed rock? It's the same question again. Okay, we should, as an answer, get 111.1 tons. So I'm going to pause it, put up the solution, and you can check your work against mine. And bam, here it is. So I've reduced the colors in this case. I deleted some of the setup, but I wanted to show you that you don't need to show every single step every single time if you don't want to. You just need to keep the essentials. So in this case, we have this much of the 75, this much of the 30%. All right. Now, number 5 is slightly different, and you might get one like this on your assignment. So let's be careful about this. Let's set it up like the others. How much solder is a 20%? How much solder that is 20% tin? So 20% tin should be added to 30 grams of solder that's 40% tin. Okay, 40% to make a solder that's 35%. So the percentages or the ratios here, they look similar. It looks a whole lot like what we've been dealing with. So maybe a lot of students will look at this and say, okay, it's basically the same thing, but the answer is it's not the same thing because of the ways that the amounts are set up. It says how much solder, that's 20% tin, so let X equal the amount of, I'll just call it 20% solder. I'm talking about tin when I'm talking about these percentages, so don't worry about that. That's going to be my 20% tin that I'm looking for. And then it says should be added to 30 grams of solder, that's 40% tin, to make a solder that's 35% tin. Well, remember this line here is my amounts line. It's the amounts in grams in this case. The second amount, the 40% amount, is 30 grams. And so normally we have a 30 minus X there, and some students on autopilot, they'll put like 30 minus X here because they think that that's the way it's supposed to be, but it's telling you right here it's 30 grams of solder for the 40% tin. And so if you're adding 30 minus X, you're not doing it right. The difference is, in the end, if we take our X plus 30, the total amount it's going to give us is actually going to be X plus 30. And that's the difference. This purpley highlighted part is the different part. It's almost the exact same question, but our unknowns, we can say, or our kind of X plus something is at the end. So you can go ahead and fast forward to the end if you know what I'm going to do now, or you can watch me do it, okay? So 0.2x plus 0.4 times 30. I always like to use brackets when I have multiplies. Unless it's x, then it's implied. And then we have our 35%, or 0.35, times this. And the rest is the same. We've got our expression set up, so I'm just going to expand this. And once again, you can fast forward this if you find this boring or not helpful. Just multiplying through here. Nothing new. On the left side, I'm going to bring all the x's to the left, which is actually going to give me a negative. But on the right side, it's also going to give a negative. That 10.5 minus 12 is going to give a negative 1.5. And then we divide both sides by that negative, and it's going to make everything okay again. Students start to panic when they start seeing negatives, especially when we're dealing with amounts. You can't have a negative amount. But in the end, the negatives will cancel each other. If they didn't cancel each other, you know you have a problem. Okay? So this is 10 grams. We have 10 grams of 20% solder. That is the answer to the question. And so we don't need to go any further. It's not even asking what the total amount would be. So we can just say 10 grams of 20% tin solder should be added. And again, sit back, try to make some sense of this. We have 20% tin. We're mixing it with 40% tin. the end result should be somewhere in between the 20 and 30. If we're mixing 10 grams of the 20% and 30 grams of the 40%, that's why we have closer to 40 than 20 in the end. We mixed more of the 40 together, so that's why it's closer to the 35% mark. If you went on to be like an anesthesiologist or something, you'd be dealing with these sorts of mixture problems all the time, because in order to make sure that someone stays under during a surgery properly, you have to be balancing the mixtures constantly. It's just a completely hands-on job. And they're dealing with this sort of stuff, but on a much more complicated level, of course. So I'm going to put down a little alternate method here. I'm just going to pop it up, all right, and take a moment to take a look through that. Pick through that yourself. What I've done is once I got to the step where I could make a choice here, I could make a choice at this step, the second step of the solution, to move all the x's to the left or move them all to the right. If you actually move all the x's to the right, for example, I've moved the 0.2 over to the right side and made it negative, you'll actually never deal with negatives. So sometimes that's beneficial, but take some time to try and figure that out, okay? I'm going to move on to question 6 now. Question 6, it says 20 grams of crushed stone, that is 80% small stone, is added to an amount of crushed stone that is 40% small stone to get a mixture that's 50% small stone. How much of the 40% is added? So once again, are you getting tired of this yet? You should be able to start seeing patterns. The idea, and I'll just set up the beginning for you. Once again, if you want to jump ahead and try it yourself, you should get 60 grams as the answer. 80% is the 20 grams of small stone, plus 40% equals 50%. These are our percentages of the mixture. Below it, we're going to be writing the amounts that I'm multiplying by. And in this case, we should see that we have 20 grams of 80. We don't know how much 40% we have, but in the end, we know we're going to have 20 plus x. All right. And now this is a slightly different question again, but very similar to the last question. The only difference is that we switch the places here. All right, so take some time to read the question yourself, make sure you understand it fully, and try this question. And I'm going to post my solution to this now. And here we go. So you can see that the solution process is exactly the same. I've let x equal the amount of 40% stone because that's actually the question that's being asked. And the rest of the question shakes out the same. I even ended up with the negatives, which divided out. So doesn't need to be different every time. Sometimes I'm just getting some extra practice going for these. Let's move on to distance, rate, and time problems. So these distance, rate, and time problems, also known as motion problems, are basically physics. They're just physics disguised as math problems, because distance, speed, and time are all things that really are in they live in the applied math world, which is physics. So distance is speed times time. D equals V times T. This is going to be very important. Another way we can represent this, and I recommend you try, is with like our unit triangle or formula triangle here. And many of you have seen something like this before. What it means is, for example, if I want distance, I normally cover that up with my finger. It's hard to show that here. If you want this, then it's speed times time. So distance is speed times time. If you want velocity or speed, it's distance divided by time. So d over t. And if you want time, it's distance over speed. Okay, so just a little triangle to help you remember. So let's use it. A car travels at a speed of 80 kilometers per hour for 2.5 hours. How far did it go? So sometimes some students find it helpful to write down what we're given. So you could write down v as 80 kilometers per hour. You could write down the time as 2.5 hours. And then for how far did it go, you could write down d. What's d? And then write out our formula. Well, d is v times t. Distance is speed times time. And we have v, we have t. We just wrote them down. So all that's left is to substitute them in. 80 kilometers per hour times 2.5 hours should give us a distance. Let's just take a look at the units. We have kilometers per hour, and we have hours on top, so hours cancel, leaving us with kilometers as our answer, which is definitely a distance, and so we know that we're on the right track. 80 times 2.5 is 200 kilometers. Final answer. So of course we need to move on and try to do a little bit more tricky example here. So there's going to be two types of motion problems that we're going to be dealing with. And I'll call them type 1 and type 2. They don't really have a name. It's just two ways to approach these problems. So in the type 1, type 1, the two distances that are going to be in the problems, and this will make sense soon, are going to be equal. So in this case, you start by first indicating that the distance 1, or distance, equals distance 2, or d1 equals d2. So start by indicating that d1 equals d2. Then we substitute speed multiplied by time for distance. What does that mean? It means that first we start by indicating that d1 equals d2. And second, we need to indicate that v1 times time, or speed times time, is distance. Right? They're equal. So that's what it means by substituting. So what it means usually is we do these two steps. So these are the primary steps that you're going to take to solve these problems, and it will make more sense as we do the examples. For the second type, type 2, the two distances we're going to be given are going to add together to make a known distance. So in this case, you start by indicating that the sum of distance 1 and 2 equals a known distance, or usually a total distance, and then we substitute speed multiplied by time for distance once again. So very similar, the only difference is in the first step. So first step, d1 plus d2 equals a known distance. That's the different part. Second step's the same. So once again, if you're wondering what the steps are for type 2, we can say, that's the difference, and the different step is really the first step. Okie doke, there's one note before we get into this problem. You must use uniform or consistent units when dealing with these problems. So what that means is if speeds are given in kilometers per hour, and say time is given in minutes or something, we need to change everything to the same units, for example, hours. So for example, maybe speed was 20 kilometers per hour, and time was given as 30 minutes. We have a problem, right? This is hours, this is minutes. So you got to make them the same. And normally it's better to change the time than it is to change the speed, because usually time is one variable instead of changing a bunch of stuff. So in order to get from minutes to hours, you divide by 60, because there's 60 minutes in an hour, and that would give us our 0.5 hours. All right, so this is just our setup for the problems we're going to do. I'm going to bring up the first problem right now. Okay, hold on to your butts, because it's time to do one of these problems, and they're a bit dense. So follow along with me, do your best to pay attention, and if you need to watch the video again, then watch the video again. Let's see what we got. Two planes are 690 kilometers apart. They leave at the same time, fly towards each other, and meet in 2 hours, or meet after 2 hours have passed. If their speeds differ by 30 kilometers per hour, find the speed of each plane. So I found it really useful to draw a diagram here. We should draw a picture of what's happening. So this is the distance between the two planes when they start, okay? The distance between them, we know it's 690 kilometers. So I'm going to write that in. That's the distance between the two planes, assuming that the first plane, starts on the left, and the second plane starts on the right, okay? Of course, it could be a top-down view, whatever, but the point is they're coming towards each other. And so we've now used that they're 690 kilometers apart. They leave at the same time, fly towards each other, and meet in 2 hours. Okay, so we also know the time. The time is going to be t, and think about this. If they're flying towards each other and meet each other in 2 hours, that's the exact same time for both. So time here is going to be 2 or 2 hours. If their speeds differ by 30 kilometers per hour, find the speed of each plane. Okay, their speeds differ by 30 kilometers per hour. Well, let me add to my diagram. In my diagram here, the two planes are going to come towards each other, going to meet somewhere in the middle. Let's just say right here, okay? In this case, let's say that the first plane is flying at some speed v1, just the first plane, so I'm calling it v1. The second plane has a speed different than the first plane by 30 kilometers. So we can say something like v2 minus v1 is 30, which would mean that v2 must be v1 plus 30, if you think through that, okay? So I'm going to say that v2 here is actually v1 plus 30, because I don't like to deal with two different variables if I can help it. Right? I like to put everything in terms of one variable. Okay, you with me so far? So what we have in this diagram is we have a distance of 690, we have the planes flying towards each other. So for example, this is flying towards that one, this is flying towards the other. That's the speeds in both directions. And just for completeness, I'm going to say the distance that the first plane travels is d1, the distance that the second plane travels is d2. Now that is a very dense diagram, and I do not expect that you would have drawn that for yourself. But now that we've done it, now that I've written it down, you should be able to at least make some sense of it and be able to make it yourself another time. Just for completeness, I'm going to draw my little triangle, distance, speed, and time. That'll help us later. Let's start setting things up. Remember that there's two types of problems. The first type is when distances are equal. The second type is when two distances add to a known distance. But look at this. d1 plus d2, that is the total distance. So we're getting two distances adding to a known distance. So this is a type 2 problem. All right, type 2 problem. That means that d1 plus d2 is going to add to a known distance, and our known distance is 690. All right, so again, this is a little tricky. There's a lot going on here. So watch this video a few times if you need to, and this is the only real way I'm going to be asking you to solve a type 2 question. So the first step is to set that down. The second step, if you remember, is to substitute our speeds. So let's do that. Again, we know that d is v times time, which means that v1 must be v1 times time, and v2 must be v2 times time, but we don't have v2, remember? We have v1 plus 30 for our v. So with that in mind, let's substitute. D is v1t plus d2, the second distance here, looking here, is actually going to be the speed, v1 plus 30, times the time that it takes, and then 690. So hopefully this makes sense. The first distance is going to be v1 times t. The second distance is going to be v1 plus 30 times t, because that is the speed, right? This is the first distance that's traveled. This is the second distance that traveled. When you add them together, it makes 690. I'm not trying to repeat the same, well, I am trying to repeat the same things over and over so you are thinking about this, but it's important that you really think through it. Okay, now that we've set this up, this is by far the most important step because the rest is just expanding. So at this point, we're going to substitute in what we know. Everything that we know from the question, okay? And we know a lot. We know that the first speed, well, actually we don't know what the first speed is, but we do know the time. It's 2, right? The time was 2, so I'm going to substitute it in for the 2, or we see t. And then I don't know what v1 is, but that's okay. I'm going to substitute t in again from here. And that equals 690. So you can probably figure out where I'm going with this. In the end, when you solve that, you should get, I think, 157.5. But let's not get ahead of myself. You can pause the video or jump through it to see what I get, okay? I'm going to expand this out. 2 times v1 plus, 2v1 plus 60 equals 690. I'm going to make all the left side group together with that v1, so that's 4 v1s, and I'm going to bring the 60 over to the right side, make it negative, and subtract it. So that's 630. Now, I've run out of space, so sometimes what I do is I just make a curtain here, and start again at the top. So divide both sides of this by 4. That gives V1 equals 157.5. Let's see what our units are. All of them are in kilometers and hours. Probably could have put hours down here, or just H. So kilometers per hour. That's V1. That's what this guy is. Our first plane is going at 157.5. The second plane, because I need to find the speed of each plane, the second plane is going to be easy to find. I just need to figure out V1 plus 30. So I didn't write V2 here before, but let's just write down V2 is V1 plus 30, which is just 157.5 plus 30. And then I can say what the second speed is. All right, that's how these things go. Again, I didn't actually use the term V2 earlier. I just used the term at the very end to try and make it clear what I'm talking about. It's the second plane. All right, so hopefully it's clear. If it's not clear, we'll try watching it over again. And if it's still not clear, of course, just write me anytime. I'm going to get back to you and I'll help you out. Or we can go over this in our extra help session or office hours. Okay? Let's take a look at the next question here, which is 8. It looks similar, but is actually quite a different question. Let's start by reading the question. A plane averaging 140 kilometers per hour and an express train averaging 60 kilometers per hour depart at the same time from the same city headed for the same destination. If the train arrives 45 minutes later than the plane, how far did each travel? Okay, so some of you are going to look at that and say, well, okay, I'll just take a 0 on this one. Don't do that. Try drawing a picture and see what you can do. Let's see what I know. I know that we have a plane averaging 140 kilometers an hour. So I'm actually going to move this diagram down because I want to give myself some space. And on the top here, I'm going to write down this is the plane. And the plane is traveling at 140 kilometers per hour. And that's an @ symbol, like, for email or Instagram or something. The train, which I'll just write on the bottom here, is going to be traveling at 60 kilometers per hour. Okay, and they're both going in this direction. They're both traveling from point A to point B, we can say. It's from the start to the finish. Okay, they're going to be going that direction. Now, what have I figured out so far? We've got 140 kilometers per hour used. We've got 60 kilometers per hour used from the same city. If the train arrives 45 minutes later than the plane, okay, how are we going to make sense of this? The train arrives 45 minutes later than the plane. So we need to keep track of our times somewhere. And I like to put everything in my little diagram. So just see if this makes sense to you. The train arrives 45 minutes later than the plane. So let's just say that the plane arrives on time. We'll just call that the time. And we can see here that it's being compared to that. So the train will take time plus 45 minutes. Whatever time the plane took, I don't know, maybe it's 100 minutes. The train will take 100 plus 45 minutes, so 145 minutes, for example. And then, in the end, it says, how far did each travel? Well, that's kind of a silly question because they both travel the same distance. And I know that because they're both traveling from this first city to the second city or a second destination. So it should follow logically that the distance is going to be the same for both. And so in that case, I'm going to say, what's the distance? Distance is question mark. Now, there's a bit of a problem. And you might be screaming at the screen saying, Scott, you're crazy because you did something crazy here. And that's this 45. I'm not allowed to use it. Do you know why? You can pause the video and take a think on it if you want. Why am I not allowed to use that 45? I'm not allowed to use that 45 because it's not in hours. My speeds are given in hours, and my time was not. So we're not allowed to do that. We need to convert that time first. All right? And so how I'm going to do that, I'm going to say the time, well, 45 minutes, I should say, 45 minutes in hours divided by 60. That's going to be how many hours that is. So if you take 45 divided by 60, it's 0.75 hours. And that is what's going to go here. All right? So I wanted to keep that in there. I knew I made that mistake from the beginning, but I wanted to keep it in there so that you could see that's an extremely common mistake. And even with experience, you might make that mistake more than once. Okay, so something to keep in mind. Just be really careful. You definitely need to convert that. But I think we have everything we need. This problem, it's the same distance, right? You're got two distances are equal. So this is a type 2 problem. This is a type 1 problem. I know it's a type 1 because the distances that they're traveling are equal. They're both traveling the same distance here. And what was our setup? If you look on the previous page, or maybe the page before that, I can't remember exactly. Yeah, the previous page, your steps are to do this. D1 is equal to D2. So it's just our distance. And you'll just set them equal, which means that V1 times T1 is equal to V2 times T2. So those are my first steps that I'm supposed to be following. And now we substitute in all the information that we know. We can call the plane V1, for example. Let's just say that this is the plane. It's arbitrary. You can call it whatever one you want. But just because this is the numbering that they use, we'll just call the first one the plane, the second one the train. Whatever. If there was a V3, maybe it'd be an automobile. That was a joke, and I just thought of it, and it was terrible. So if you didn't get it, it's not you, it's me. Let's plug in our known information. So V1, where's that? V1 is over here, 140. 140. T1, how long does the first plane take, or that plane take? Sorry, I'm mixing my words up. Plane, train, plane, train, plane, train. It's T. It's right here. And so, the second one, the train, what's its speed? 60. How long does that train take? That train takes T plus 0.75. And now, if you look really carefully at this expression, the only unknown is T. All right? The only unknown is T. Why am I looking for T? I'm looking for T because I couldn't find D. I'm trying to get T first, and at the end, I'll get D. All right? So it's kind of a two-step process. This would be our first step here. So you can jump ahead in the end if you want to try this yourself. Your time should be, your distance should be about 79 kilometers, 78.75. But you can follow me to the end of the road if you want. Expanding this on the right. So 60 times 0.75 is 45. Bringing my t's to the left, I end up with 80 t. 140 minus 60 is 80. 45 was left on the right side. Divide both sides by 80. That's 45 divided by 80. 0.5625. Remember, our units here are in hours. Actually, I don't want to confuse you, so I'm not even going to put that in a box, because that's not a final answer. I'm going to continue onward, because our story is not finished yet. So if we were to take this into two big pieces, I would probably say that this first step here, or this would be kind of step 1, and we'd have a step 2, which is finding distance. How do we find distance? Well, remember our handy triangle? Distance is speed times time. So the distance is the same for both. I'll just go ahead and take any old speed and take any old time and use that. So I'm going to use this one. I'm going to use that one because it's easier. So D1 is the same as D, which is equal to V1 times T1. That's 140. It's not really V1 or T1, is it? It's just T. 5625. That's my distance. What's it going to be in the end? 140 times 565 is going to be 78.75 kilometers. Make sure that your units are correct, because the question is talking about kilometers. Don't like throw meters there. Don't keep it dimensionless and so on. So I should probably answer the question. It says how far did each travel? Each traveled 78.75 kilometers. And I hope that makes sense. They're both traveling the same distance. So 78.75 is the length of this path from point A to point B that they're going along. All right, so again, these questions are not easy, but they're all sort of set up in a similar way. All right, I will do one more like this so you can see how they're set up. But for now, try to make sense of this. Number 9, I'm not going to be asking you this. I'm just going to tell you to skip it. It's more of a physics question. I'm going to say you can try it as a challenge if you want. If you do try it, you can send me your answer, and maybe you'll get a bonus point for it. But for now, I'm not going to be expecting you to do that. If I do expect you to work on it later, I'll tell you well in advance, and we can try it then. 10, the last one. Trains at each end of the 50-kilometer Ural tunnel under the English Channel start at the same time into the channel. Find their speeds if the train from France travels 8 kilometers per hour faster than the train from England, and they meet in 17 minutes. So I'm just going to put a little diagram up. There's a little picture that I can show you. All right, and there we go. So this question is very similar to the previous question, okay? That's what I'll tell you. The only difference is that instead of the time being the unknown, we have a speed really that's unknown. The time is known. So go ahead and try this yourself, I recommend, but I'm going to write out my answer and you can see if yours matches mine. So the trains, we have trains at each end of the tunnel. Let's draw a picture for that. I know I have a picture there already, but you're not going to have that on the test. So we've got England on the left side, France on the right. So I'm just going to say, let me scooch this over. I'll say that this is England side. This is the France side. They're not the same letter, be careful. And we have these trains coming towards each other, so they're going to meet somewhere in the middle. I'm just going to put a line there to represent that. The distance that the first one travels is going to be d1. The distance that the second one travels is going to be d2. And I should probably mention that there's 50 kilometers in between them. This isn't a chemistry course, so I don't really care too much about the decimals. 50 is fine. What about the speeds? Well, the speeds that they're going to be traveling, it says that we need to find their speeds, but we know that the train from France travels 8 kilometers faster than the train from England. So once again, we should say that the one being compared to is our variable. So the train from England is going left or right at some speed v, and then the train from France coming the other way is going to be that speed plus 8, or plus 8 kilometers per hour. I'm just seeing here that in their diagram they're meeting over there. So you don't need to move this, but just for the sake of being more accurate, I'm going to move it. Again, you do not have to make that change. It's totally irrelevant. So I think I have most of the things that I need. I know that they're meeting in 17 minutes. So I should probably put down time is t. And I know that t is 17 minutes. My speeds, once again, are in kilometers per hour, so I need to convert it. So time is not 17 minutes. It's actually going to be 0.283 hours. All right, I've divided by 60. And I just decided to take 3 decimals. This problem is a type 2 problem. We know it's type 2 because the distances are being added, okay? The distances are being added to some known distance. So I'm going to write that down. d1 plus d2 equals our total distance, which in this case is 50. I'm not going to keep the decimals, just 50 is fine. We don't know those distances, but we can break them up. because we have v1t plus v2t. So I'm actually going to keep it there this time, just so you can see. Sometimes you can write more. It's up to you. d1, v1, t1, d2 is v2 times t2. And let's go one step further and substitute what we really know they are. So v1 is v. Our time is 0.283. v2 is v plus 8. Remember, v2 here is v plus 8. If you get lost, rewind the video, try to keep track. And our time, once again, is exactly the same. It's the same time for both. This equals 50. All right, now all we need to do is expand. So I'm going to pause the video and expand it just to save time. And this is what we get for our speed for the English train, the one coming from England. Notice that in the end, I took 3 digits. I kind of followed just a significant digits rule from, say, chemistry, if you've done significant digits. But don't worry too much. You know, if you don't know how many decimals to take, then take at least 1 or 2 or maximum 3. We don't normally need more than that, okay? Just enough to keep your answer clear and fairly precise. So this is the train from England. Our last step to find v2, I guess, is just to say our v plus 8 is going to be 84.3 plus 8. So our speed here, let's label them. We have v from England and v from France. Again, that's optional. I just want to be clear as to what I'm talking about here. And that would be 92.3 kilometers per hour. That's our 2 speeds. All right, that's how we do these problems. And if you compare this to the other type 2, you'll notice that I actually did almost all the same stuff, just slightly different. So their speeds are as follows. I'll just save some time and say this is the English train. And this is the France train. And if you wanted to check that it works, do v1 t1 plus v2 t2, and you should see that they equal 50. All right, and I'll pop that little check up there. And there it is. You can see that it actually works out to just about 50. And you can look through what I did for that check if you want. That's just optional, nothing that you need to do. And that's it for this worksheet. So if you have questions, which if you're going to have questions, I think this is the place you're going to have them. This is some tricky stuff. Keep a track of them. Let me know which question you need answered, and I'll answer it either by email or on the Teams or in my office hours or during our tutorial session in class. All right, that's all for today's lesson. Take care and do good practice. I'll see you in our next class. Bye-bye.